Okay, so let's start. Good afternoon, everyone. Commencing the workshop on the behalf of KSV and Ldrp, I warmly welcome everyone that has joined us in the workshop this evening. So before moving forward towards the workshop, let's have a quick introduction about KSV and Ldrp. So KSV, Kadi Sarva Vishwavidyalaya, is a university that was established with the Gujarat State Act 21 of 2007 and was approved by UGC. The university has been set up by the Sarva Vidyalaya Kedavani Mandal, a trust that has been in the existence for more than 100 years to provide the need-based education and develop courses of contemporary relevance to be a university of excellence by providing research and skill-based activities and trainings which would foster higher economic growth and provide the education to all respective of caste, creed, and religion. Now, talking about Ldrp Institute of Technology and Research, it was established in 2005 and 2006. The college has made steady progress during the past 16 years of its existence. As a prestigious state institute, Ldrp Institute has long recognized its role in engineering, education generation, and dissemination of useful and relevant technological, industrial, and economical development of the country. And now, Ldrp and KSV has brought to you this immense experience through the Break the Barrier event, which is a compilation of various interactive workshops from industry experts, working professionals, experienced developers, CEOs, and more, where you can present your revolutionary ideas and skill ups through the competitive environment that will be presented by the hackathon and grab the opportunity to win the excited prizes. So among these 14 plus workshops, today we'll be conducting our data engineering workshop, which will be followed by our Snowflake workshop. And on that note, I would like to introduce our presenter for today's workshop, Mr. Rahul Jain, a data engineering manager at Snowflake with 12 years of experience and in-depth knowledge in data engineering, master data management, data integration, and data warehouse design. So without any further ado, I would like to hand over to Mr. Rahul. Good evening, Mr. Rahul. Grateful to have you on board.
Hey, good evening, everyone. Good evening, Khushbu. Thanks for a nice introduction. I hope I am loud and clear.
Yes, yeah.
All right, wonderful. Thank you, guys. Thanks, everybody, for joining this on time. I know it's Sunday evening. So it's one of the most challenging and difficult part. I know that, but I really appreciate you guys took up time to join this, and I hope I could add some value in understanding the topic about databases, data warehouses, and Snowflake. Yeah. So without further ado, let's get started. So let me share my screen here. And I hope all of you have access to your browser. And what we are going to do today before we start getting into the topics, I just want to gauge the participants, what all background you guys come from, right? So in order to do that, what I did is created two surveys here, which you can take online right now as we speak. So first one is related to your knowledge about cloud computing. It's just to check the background of audience, right, guys? There is no assessment on that, right? So it's just a quick survey. If you guys can go to your browser, or if you have mobile phone, then you can use mobile phone as well, and open this menti.com, www.menti.com, or you can use this QR code, right? So once you do that, and you have to enter the code here, which is 90543098. So I have two questions for you, just to check, how much comfortable you guys are with the cloud concepts, right? So just go to your menti.com, right? Or use this QR code and start. There are two questions, just to start answering those questions. Yeah, I see some people already started that. So I'll just hold on for a minute till all of you respond to this, and then we'll see the results, right? And to check the pulse of the audience, all right? So I'm repeating this again. This is a quick 2-question survey, which you have to take. So you can do using your laptop or desktop, wherever you are, using your browser, or you can use mobile phone as well. Just scan this QR code and start answering the question which comes to you. Let's see how audience is responding to this question. So the first question I asked here is, just a moment, guys. Let me make sure. Yeah. So first question was, what features come to your mind when you hear the term cloud computing? So basically, what do you understand by cloud computing? Right. So here I see some responses. People says Google Drive, data over internet, storage, virtual machines, cost saving, faster, physical servers, Google Cloud, Azure, AWS, Chef. Yeah, still some responses are coming. Service over internet, Puppet. Okay, interesting. Some of you are, I think, testing with it. Some, because I see responses like A, B, A, H, H, H. I don't know if these are the uh, like short form of something or acronym. Remote. Okay. Kubernetes. All right. Interesting. Programming. Data storage container. Okay. All right. So some of the terms, I think everybody can relate to, like AWS or um, Google Cloud, right? Or scalable, elastic, always available, fast computation, yeah, unlimited scale. All right. So let's jump into the second question and see how the responses are. So my second question was, how familiar are you with any of the public cloud? So there are three major public cloud available in the industry: AWS, Azure, and GCP, which is Google Cloud Platform, right? So I think there are total around 20 responses, or they are still increasing. All right, so 12 of you says not familiar at all about these public clouds, okay? And 7 says have theoretical knowledge but no hands-on, and 2 of you have the hands-on exposure. All right. All right, so not familiar at all, that bucket is increasing. All right, I get it. Okay, so this gives me some indication how I should start this session and what all basics I have to cover before we go ahead. Okay, so thank you so much, guys, for responding to this. I have one more trouble for you, which is another survey related to the data warehouse or databases. So let me open this. Again, this survey also has 2 questions. So I'll present it. Again, you guys have to do same thing, guys. This is the last time we are doing it, okay? Don't worry. So this is just to check how familiar you guys are with data warehouse or the Snowflake. All right. So again, do the same thing. Scan this QR code or go to manti.com or enter this passcode. Yeah. You guys already did the first survey. Please participate in this as well. And then we'll get started with the session. All right, some of you still started responding. Just good. Meanwhile, let me connect to my another monitor, which will help me present this session better. All right, guys, please respond to this survey as well. This will help me to determine, right, what, how should I stitch my session right now? What basic concept I should cover, or I should jump to the advanced concepts. So let's see the response. All right, wonderful. So 24 of you responded. How familiar? So the question was, how familiar are you with data warehousing or ETL? Right, these are the terms which are used in data industry. Right, I know some of you are still, uh, you know, pursuing your degree, and some of you could be experienced professional. All right. So how familiar are you with data warehousing or ETL backgrounds? So out of 26, I think half of the folks, 13 people says not familiar at all. 10 of you say familiar with the concept, but no hands-on experience. Okay. 3 of you says experienced data warehouse and ETL professional. All right. So these 3 guys will help me during this session. Okay. Wonderful. Let's jump into the second question. All right. The second question says, how familiar are you with the Snowflake? Snowflake is a very trending term these days in the market. So I just want to check, do you guys know what is Snowflake? Right? Or what level of knowledge you have about Snowflake cloud data platform? Yeah. So again, 25 responses, 18 of you, all right. Most of the chunk says not familiar at all. And 7 of you says heard about Snowflake, but no hands-on experience. All right, wonderful. Now I got the pulse of the audience, guys, all of you. Let's jump into the. So I prepared this session specifically to talk about Snowflake mainly, but I think we'll quickly cover what is data warehousing and a little bit about cloud computation or cloud computing, right? We'll not spend much time. We'll only spend, let's say, 10 to 15 minutes covering these two topics: data warehousing, first cloud computation or cloud computing, and second data warehousing. And then we'll jump into the Snowflake part of it. All right. So it's 5:26 at my clock. So I think we'll run this session for next 45 minutes to 1 hour, and I will be open for your question and answer if you have any, right? And unfortunately, this time I will not be able to go too much deep into the topic, right? Because these all are itself a very big topic to understand. So I'll just scratch the surface so that you guys know the basics or fundamental of it, and you guys can start learning these things by yourselves. All right, so let's jump into it. So I have not prepared any slide for cloud computation. I thought we'll jump directly into Snowflake topic. So let's talk about, I'll just search something randomly and I'll explain what is cloud computing. Okay. So simply, guys, if I put it very simply in simple words, right? All of you have your laptops or desktop, right, which you use as a computer. So if you want to perform any processing, right, if you are writing any code, you want to execute any code, or you want to deploy any applications, create any website and host it, right? So you have two options. One is you can create or host your code on your laptop, which is your local machine, right? So whenever you execute that code, that piece of code will be running on your laptop, right? Which is something called on premise. That means your code piece of code or any processing happening on your personal laptops or desktop. Now, I will not call it laptop or desktop, rather in the industry term, I will call it server. So any form of computing, if you want to perform, and if you're doing it on a local machine, which you are managing, which that is called the on-premise installation or servers, right? Now there are various shortcomings with this method. So earlier, when cloud was not into picture, that time people used to do on-premise hosting. That means any computing is running on your local machine or local servers. This was in the legacy old days, right? But now there were some limitations with these kind of methods. One is you have a limited computation, right? You have a limited RAM or your processing power, right? But the moment the use of data started growing, and we have now big data related use cases, more and more data getting generated, there was a need of a bigger machine. So what people started doing is they used to buy servers, right? Physical servers. You might have seen in the data center something like, you see here, these kind of servers, right? These are called data centers. So when your computing need grows, right, then you need more and more machines, because you cannot perform all the computing on your laptop or desktop. Then what you do is you buy these kind of hardwares, right? And you create a kind of small room where you, based on your capacity or requirement, you purchase the hardware and computing power, and you just host all your computing on these servers, right? But just think from an individual perspective, or any small companies or startups, right? They are coming up with the new age applications, right? Or mobile application, desktop application, whatever, right? For them, setting up this data center and these servers is a huge task. Also, it's very expensive and costly. Setting up and then maintaining electricity, like cooling, temperature, and you need special people to manage these things, right? So what these three cloud providers, right? There are many more, but these three, like AWS, Azure, and Google Cloud, these are the leading cloud provider. They came into the picture and they say that you don't worry about these data center. We will create the bigger data centers, right? And it will be kind of a marketplace where anybody can come and rent our servers, right? So the volume you use their servers or the capacity, only that part you will pay to them, right? So that is called the cloud hosting or cloud computing, where you are not running your piece of code or application on your server which you maintain. Rather, you are running these application on somebody's else servers, right? So these companies like Amazon, Google, and Microsoft, they have the bigger data centers, right? And anybody can log into their console and rent some virtual machine, let's say, or databases, right? Those things. And you pay only what you use. Earlier, you had to maintain the whole data center, whether you're using it or not, you have to maintain it. But now with this cloud computing, you only pay the cost which you use. So they have various services. These cloud vendors have various services like database services or virtual machines, storage services, right? And website hosting. Like there are various services. Now, what is the benefit here? So first of all, it's you need not to set up these data center on your own. Second is it's highly scalable. That means today you need, let's say, X amount of computing power and Y amount of storage. And let's say your application or software gets the popularity, and tomorrow your you need a 10x kind of capacity or computation. Then it's difficult to buy a server and procure it and install it, right? Directly you go to this cloud provider and automatically they can increase your capacity based on the traffic you are receiving. That is called the auto scaling. So you need not to worry about scaling your backend infrastructure. This is second benefit. Third benefit is it's always available because these big giant companies are maintaining this data center and they have a lot of backups and replications, everything, all the necessary maintenance they are doing. So these data centers or servers which are on cloud, they never goes down. So you need not to worry about your application going down or not available. So scalability, high availability, right? And pay as you go or pay as you use, some people say it. These are the three fundamental benefits of any cloud computing. Yeah, I hope this is clear till now. What we're so this is very basics of cloud computing, guys. Um, Now we are a little bit. We'll be talking about for next 5 minutes. I'll be talking about what is data warehousing, right? Because ultimately we have to talk about what is Snowflake. So I'll go to what is data warehousing now. So I think most of you will be uh, familiar with databases, right? What is database? If you want to store any kind of data, right, somewhere, then you need a database management system, right? So like we have file systems, like we store files in our hard disk. Similarly, if you want to store the data and retrieve the data using the structured query language, which is SQL, then we need the databases. But then what is data warehouse, right? This is the database everybody knows, like SQL Server, Oracle. These are the typical databases we might have heard about. But what is data warehouse then? So data warehouse is simply, as you know, the English term warehousing, right? That means you are storing data coming from multiple places, right? So in a big organization or any enterprise, when data is getting generated by different applications, right? Take an example of a bank, right? Bank or financial institute. So you go there as a customer, you open your saving account, checking accounts, you do KYCs, you open Demat accounts, right? Fixed deposits, recurring deposits, various product that bank has to offer. Internally, how they manage it, they have various applications to cater to these products. And they store your data at various places, right? Once when you visited them to open a saving account, second, let's say after 2 years, they ask for your KYC data. So all this data is getting stored inside the databases. Now, as we all know in this new age, data is a oil, right? They say it, which means it's very important because if you have enough data of your customers or any entities, right? And if you analyze it well, you can do the wonders, right? In terms of you can increase the user experience, you can market yourself well if you have the data, you can cross sell or upsell your product if you know your customer well based on the data. So all this data within one organization, if they want to collect at one location, right? That location is called data warehouse. Now, data warehousing is a common term, right? It's a functional term. Now, how you implement data warehousing, this is each individual choices, right? So you can implement your data warehouse on a database like Oracle or SQL Server, or you can implement your data warehouse. Like when I say implement, that means collecting the data and storing it somewhere. So you can store this data, all the data somewhere on premise. Now, if you connect with the previous talk, right, on premise, or you can implement this data warehouse on cloud. So earlier, when I started my career, right, that in 2009-10, around that time, this cloud computing was not that famous or not in trend. That time, we used to store all this data. So I remember in my first job, right, we were required to create data warehouse for a banking organization. So it took us 3 months to order the physical servers, install the Oracle database on that, and then started storing the data, creating data warehouse on Oracle. And it took us 3 months to set up this, right? But now with the power of cloud, if you want to get Oracle instance, you can get it in like just 5 minutes or less than that, right? Because you're not worrying about the underlying infrastructure, which is hardware part of it, right? So let's jump into the cloud data warehouse, right? So as I mentioned, you can implement your data warehouse on premise or on cloud. So there are various products in the market or various companies which supports the cloud data warehouse, or they offer you the data warehouse on cloud, I can say. So if you have heard about the terms like AWS Redshift or Google BigQuery or Snowflake, these are the three trending cloud data warehouse in the market. Yeah, so let's jump into it and explore. And I'll just, I don't know the format of the session. Khushbu, if I can take questions in between for 2 minutes or so, if that is okay.
Yeah, it's okay.
So anyone, guys, I'll just take a quick pause. And before we jump into the Snowflake related um, details, please feel free to ask any questions if you might have. You can just put this on the chat window, or you can unmute and speak. So feel free to unmute yourself, guys, if you have any question. If not, I'll take a pause for. Okay, so Mr. Raghavendra is asking it, is it required any prerequisite? No, so the prerequisite to launch Snowflake is just a browser. That's what, guys. You do not need any software to be installed, any driver to be installed, because that's the beauty of cloud. You do not need all these things. You just need a web browser and you can start interacting with Snowflake. I'll come to that, how you create a Snowflake account and start exploring this. I'll come to that towards the end of the session. But I just want to give an overview what we are talking, just scratching the surface about Snowflake. That's it. All right, no questions. Then I think this is a very good question you asked, Rakhin, about prerequisite. If no further questions, let's jump into the slide directly. All right, so some of you might be observing this is 2017 slide, or I know this is the old one, but I just wanted to cover very basics of it because this Snowflake training almost takes like 30 hours or so to complete full end to end. So today we are just scratching it. We are not going into any details. All right. So let's talk about overview of Snowflake, what it is exactly, right? So now I'm just trying to communicate the real challenges in the data world. So this is for data engineers, data scientists, database developers, right? What are the challenges these guys are facing in the real world, right? So let's see, and how Snowflake is solving that. That we'll see, right? So loading data, right? So all of you must have heard this somewhere, that volume of data, variety of data, and velocity of data. Three V's are increasing day by day because of the penetration of internet, technology, applications, mobile phone. Everybody is generating so much data. When you interact with your social media account, you're generating some data. When you like, comment, share, create posts on social media, you are generating data. Similarly, there are IoT devices like sensors installed on your, let's say, smart devices or electric vehicles. Everything is, or automated cars, everything is generating this data. So data from multiple sources, divert formats. So let's say relational, non-relational data, unstructured, structured data, variety of data is increasing, and immediate need. So we cannot wait for somebody to provide the data in 2 weeks or 3 weeks, right? We need to analyze this immediately. So this is the challenge which is growing day by day. This is one of the challenges, I would say. Second is integrating the data, right? So there are multiple systems which are generating data, as I mentioned some of them. And how you integrate all these systems and put your data at one place, which we termed as data warehouse. This is again a challenging part. How you connect to various data sources and put it at one location, which is your data warehouse. Earlier, it was easy because you had very few sources like CSV files or relational database. Nowadays, you have variety of sources. Now, third challenge becomes is analyzing this huge data, right? Which is, very big in volume, variety, and velocity. So our legacy systems are very slow when we talk about analyzing the data, like creating reports, charts, visualizations. Those things used to work well with the traditional systems. But when you talk about big data, then there is a challenge how you do it. And the last thing, which is very important these days, is collaboration. Right? So now people are not working in silos, rather within the organization or outside the organization, right? You need a lot of collaboration, how you share your data, right? How you collaborate with third parties to integrate third party data as well, to generate some smart analytics, right? For example, I'll give you a very basic example, right? This is all very theoretical, but let's come to a real world situation, right? So for example,
Hi, sir. Sorry to interrupt. Someone has asked a question on chat. Can you look up it or can I speak?
all right, so Pratik is asking, can we get
Yes.
started with Snowflake for free, unlike other cloud data warehouse services? Yes, you can start. I'll talk about it. I'll just show you how to create a free account and how long it is valid. So Pratik, just hold on for some time. We'll get there. All right, so I was talking about a real world example where you can see the power of data and how companies might be using it. So I'll give you two examples. So one is, I think most of you might have, or I think all of you might have used Amazon.com or Amazon.in, right, for online shopping, etc. So what Amazon does, their data engineers do or data scientists do at the back end is, there are some festive seasons in Amazon in India during Diwali or New Year's, right? And similarly in US, they have Black Friday, Christmas sale, right? Those festive seasons where they're expecting more and more orders. So what these guys do, based on the historical data patterns, Amazon engineers or AWS engineers, they try to predict the workload or the number of orders which might come for particular products. So they have, I think, millions of products listed in the website, right? So how do they manage inventory? How do they know how many products they should keep in their warehouses? So using the power of data, Amazon or any other e-commerce platform, they try to predict what is most selling product, or maybe in upcoming next 1 month or 3 months, what all inventory they should manage based on the power of data. Similarly, so they have their own data inside their databases, right? So they might be collecting this data and putting it somewhere in the data warehouse and then running analytics on top of it. But this is the internal data. Now, there's the need of blending this data or joining this with the third party outside data. So for example, very simple example is weather data, right? So let's say your Ola or Uber cabs, right, which you book through mobile phone. How do they predict the availability of cab drivers, or where should they send their cab drivers? So based on their historical patterns, right, where they get the traffic from. Another data which could be useful in this scenario is weather data, right? In particular city, how's the weather? If it is more rainy, then less people, supposed to take the cabs. Or if it is weekends, then less people will book the cab from the office locations, etc. Right? All right. So these are the kind of third-party data sets like weather data, population data, geographical data, which a company can use from open internet, or there are various companies which provide these third-party data. So these are a couple of real-world scenarios where using the power of data, these companies try to predict few user behaviors, right? And this is so huge that they need an unlimited kind of storage. They cannot predict in advance how much storage they need, how much compute power they need. Yeah, so these are the struggles like loading, integration, analysis, collaboration. These were the typical problems with the traditional databases or on-premise databases, right? So this slide says this struggle ends now, and this is the symbol of a snowflake. So what is Snowflake, right? It's nothing but a data warehouse which is hosted on cloud, right? So these are the benefits. So Snowflake is not nothing but just a data warehouse. You can store the data inside. So like Oracle or SQL Server, you can store the data. I know it's very advanced than that, but just to give you some analogy, you can store the data, you can query the data inside a Snowflake. And these are the benefits of hosting your data on cloud. So Snowflake is a complete SQL database. So the way you interact with SQL Server, DB2 or Oracle, same way you can interact with the Snowflake database. And this is very important, zero management. You need not to install, upgrade any software in order with Snowflake, because it's already created on cloud. And these guys, Snowflake companies or support team manages those installation or patching or upgrades, like release management. All those things are done on cloud. All of your data, this is also very important. That means you are not restricted with any capacity. So you can store a single KB of data to multiple petabytes of data. You need not to predict the capacity in advance. So when you go to and buy your laptop, right? So you give the configuration that you need a 1 terabyte or 2 terabyte of hard disk, right? This is estimating a capacity, how much you might need. But in these cloud related softwares or platforms, you need not to predict any capacity in advance. So this can store all of your data. That means unlimited storage you will get when you go to Snowflake. All of your users, multiple users can connect to Snowflake, and that does not hamper its performance, right? Unlike other databases. And the last very important part is pay only for what you use, right? So for example, I have my laptop, my MacBook, whatever, and I purchased this with the highest configuration, let's say 2 terabyte of hard disk and let's say 64 GB of RAM. But if I'm only using this to watch YouTube videos or Netflix videos, right, then I'm not utilizing my machine or laptop to the optimal capacity. But still I have to pay what I already subscribed for, like 2 terabytes of hard disk in that configuration. But when you go on cloud, whatever you use, the amount of resources you use from that cloud location, only for that you will pay. So if you store, let's say in Snowflake, for example, 10 gigabytes of data, you will pay only for 10 gigabytes. If you store 100 gigabytes or terabytes, petabytes, whatever, then you pay accordingly. So there is no upfront fees or no licensing fees. which used to be there in the traditional databases like Oracle or SQL servers, DB2, SAP, all these databases. Here in terms of Snowflake, there is no upcoming or licensing fees. You pay only what you use. So these are the 5 key breakthrough why Snowflake is very famous these days, right? It's a complete SQL database. So it's very easy to access your data because SQL is relatively easier and familiar languages for data engineers or database developers. So simply you can use the same SQL language which you are aware about interacting with Snowflake. I'll skip few slides because these are very detail oriented, but I'll just focus a little bit whenever I feel it is important for you. Right. So one key breakthrough in Snowflake is you can store structured, which is relational, as well as semi-structured data, which is not relational, like JSON, XML, and Avro, these kind of data. All right. So how all this works, like how Snowflake manages this? Because you have to understand the architecture, right? How, because we discussed about the benefits too much, but how all this works, let's see that. Right. So this might be a little technical for you, more technical, but try to understand this, right? So on the left hand side, these are the traditional architecture of distributed systems. And on the right hand side, there is a Snowflake way of doing things, right? So this is traditional architecture for any data warehousing. So there were 2 very famous architectures traditionally. One is shared disk and shared nothing. That means, so you see these top nodes, so in any software applications, there are 2 things. One is compute and second is storage, right? So for example, in your laptop, you have RAM, random access memory, which which plays the part of compute, or your microprocessor, right? That participate in computing things. And your hard disk acts as a storage element. Right? So there are always 2 terms. One is compute and second is storage. So traditionally what used to happen is in the distributed system, the famous architecture was a shared disk architecture where different compute machines, this is a compute node, sharing one storage location. This is called shared disk. So there is one disk and different compute resources are accessing the same disk. Why I need different compute resources? Because if my compute requirement is going bigger, right? I need a horizontal scaling. I need more and more compute nodes, but I'm storing my data in one shared disk. Another architecture was share nothing. So you have one compute. This is our laptops, right? This could be my laptop. This could be your laptop. So where is nothing is shared. Compute and storage are coupled together. These are the traditional architecture. But with Snowflake, this is a good blend of both the architectures. So it utilizes both of these architectures had some benefits, some drawbacks, but Snowflake combines both of these architecture, and we'll see how this does that. So this is the typical architecture of Snowflake, where they have a centralized storage here, which is distributed, and they have this compute layer on top of it, which is also scalable. I will not go too much into details, guys. I'm just trying to put very basic concepts here. So compute and storage, these are not tightly coupled. So when you need more compute, you can increase your compute power. If you need more storage, you can increase your storage power or storage capacity, I would say. So if I give you very real-time example, so again, in your laptops or your desktops, right, there is some limitation how, so let's say you purchased your laptop and which has 16 GB of RAM and Intel i7, like dual core or whatever processor, right? If you want to increase your compute, right, performance, then what you will do, you will go to hardware shop and or any laptop shop, and you will install one more 60 GB of RAM, 16 GB, sorry, and that's how you will have 32 GB of RAM. So that's how you increased your compute power. But there is some limitation of your processor that you cannot increase your compute power unlimitedly. Like you can increase from 16 GB to 32 GB, or let's say maximum 64 GB. But if you increase more than that, then your motherboard or whatever hardware will not support it. But that's not the problem in Snowflake. In Snowflake, you can unlimitedly, because it is on cloud, you can increase your compute power unlimited and as well as the storage power also. So that's the benefits of this architecture. And its difference with other databases like performance, concurrency, simplicity. I'll skip this slide. And this is the old slide which says there are almost 550 plus customers. This is in 2017. But as we speak in 2022, Snowflake is so popular in the data industry that it has crossed almost 6,000 customers. So it has grown 10 times in last 5 years, right? And various top like Fortune 500 companies use Snowflake for their cloud, for their data warehouse strategies, right? So let's go ahead. Enough talking about these theoretical concepts in slides. I'm not a big fan of slides though. I see a couple of questions in the chat window. So let me do this, okay? Let me just explain for next 15 minutes. And you guys can also create a free Snowflake account. And I'll tell you how to create it and how you start using Snowflake. And then I'll come to this question answer in the end. I hope this works for you. So as I mentioned, you just need a web browser. Any web browser like Google Chrome, Firefox, whatever you like. You just type signup.snowflake.com. I'll just paste this in the chat window. Don't do it in parallel with me. Just understand what is this, right? And then you can do it later after the session. So what we are doing is we are creating a Snowflake account, and you will see in 2 minutes we can create a Snowflake account and start putting our data inside it. Okay. So signup.snowflake.com. This is the URL we'll hit, and this opens the Snowflake portal website. Here, somebody asked, right, about the free trial version. So Snowflake gives us 30-day of free trial, right? Like AWS and Azure, they give some free trials, right? 30-day free trial and $400 worth of credits to use. All right. Anybody can go ahead and open a Snowflake account. So what you are doing is you have to put your name, like I'll just do it quickly. First name, last name, email, company, I'll say ABC for now, and India, right? And you have to say here continue. So these are the very basic details you will put. We will say continue. Here you will see different editions. So there are 3 editions in Snowflake, like standard, enterprise, and business critical. So enterprise and business critical are used mostly by organizations, but for our basic use, we can go ahead with the standard edition. Now, there is very important thing which I missed explaining during the presentation is Snowflake is nothing but a SaaS application, which is software as a service, right? Snowflake, they do not have their own data centers anywhere. So when you create a Snowflake account, you have to choose which underlying cloud provider you want to go with. right? So Snowflake can be hosted on either Azure, AWS, or Google Cloud. And Snowflake uses internally these famous cloud platforms data centers. Okay, so AWS is very famous these days in the industry. So you can choose the edition and you can choose the cloud. So guys, there is no difference. You create a Snowflake account on Azure or AWS or GCP, there will be no difference in user experience or in our experience as a developer, because we will not be dealing with these cloud providers. We will directly dealing with Snowflake. So I just choose AWS and it asks for region, which region you want to host your Snowflake. Right? So you can choose an Asia Pacific or whatever region you are, and you simply say get started. The moment you click on get started, it says account setup in progress. Right? And it says an email to activate an account has been sent to my email ID. It may take a few minutes to arrive. All right, never mind. So I just go to my mailbox and I'll see this email should have come by now. Let's see this. All right, so it takes around 1 or 2 minutes to get this email. And you guys can also do the same. You just need to provide these 3, 4, and 4, 5, 6 information data points, whatever, and your Snowflake account will be created for 30 days. So I already have one Snowflake account created. So I'll just log in. So you will receive, let me see if I have received the email. Yes, so I got the email here. So you'll see something like this. Congratulations, you have received the Snowflake, created Snowflake account. You can say click to activate. And this is the URL, your Snowflake account URL. You just go to copy and save somewhere. And I'll say click to activate. It will open this URL. And you can set your username, password, right? So I'll just say my username is, let's say, Rahul. Password is this, confirm password. I'll say get started. Yeah, so that's it, guys. I'm done. So now I can put in my username here and password. This is the home screen or login screen for Snowflake. Remember, this account URL you have to save or bookmark somewhere, because this is your unique endpoint or URL through which you will be accessing your Snowflake account, right? Whenever you want to. Or the moment you will hit this URL, you will get this screen and you will sign in. That's it, guys. You are inside Snowflake. And see how fast it is. It just took us 2 minutes to create a Snowflake account. And now unlimited opportunities are open for you. Unlimited storage, unlimited compute, right? So this is a lot of feature. I'll not go into too much detail. I'll just go into, let's say, worksheets. And this is how you create a databases tables, right? So this is the screen where you can create database, you can create tables, you can store the data, any kind of SQL you can perform here. Right. So for example, there are some sample queries. Right? These are some sample queries provided. These are very, complicated or complex. Let's go to database. And when you create a Snowflake account, it gives you sample data set by default. And you see here like weather data or customer data. These are the some sample data sets you need not to store. For example, this left-hand side, you will see this object pane, which is database, schema, and tables. And you can start writing query here. You can say select star from, let's say, customers. I'll say first the database I have to select. So I'll select simple data. This is one, and I'll say customer. And I'll say, let's say limit 100. or just to give me 100 records, otherwise this query will run for long. Simple SQL you can run, and right hand side you see this run button. You click here, and bottom you will see the results. Right? So you see the result, customer key, address, customer. This is sample data. So guys, I know you guys are in this era. We create all our cloud account like this, right? But earlier, believe me, when we used to install Oracle or SQL Server somewhere, it used to take a lot of time. Compared to you create a Snowflake account, and within 2 minutes you can start executing your queries here. And it gives you a lot of aggregation on the right hand side, customer key distribution, phone number filled or not, right? 100% filled. So these are the advanced analytics which Snowflake gives you with this query. Right, so this is a typical database you can use Snowflake as. There are various advanced features. I'll not go into too much details about the advanced feature, but if you want to play with it, just go to signup.snowflake.com and create your account. This is a free trial account. It doesn't require any credit card or debit card information. Right, I have created this account in front of you. You need not to put any credit card information, and you can use this for 30 days. And I think they are giving some bonus as well. So not only 30 days, you see here 48 days trial left in trial. So though it says 30 days, but I think they've given some extra days. So this is 48 days of trial you can use. And after these 48 days, you can put in your credit card information and can continue using it. But there is a hack. If you don't want to put credit card information, after 48 days, you again want to use Snowflake more, then you can create a new account. So right now they are not limiting number of account you can create using one email. You can create as many account you want. I don't know how long this will be valid, but right now this is the fact. Yeah, so let's quickly jump into some of the questions you guys might have. And I see some questions in the chat window. Let me. So one question is asked by Raghvendra, which is, sir, which all inputs they take for predictions? Guys, this is not a data science class. So, I mean, I don't know which all inputs they take for predicting the customer orders and all, right? There are various algorithms they might be following. Naveen Kumar is asking, hello Rahul, compare the data difference between Snowflake, Redshift, and BigQuery. All right, Naveen, I'll come to that in a while. Just hold on. So Snowflake is a cloud data warehouse platform similar to, there are competitors of Snowflake, which Naveen mentioned. So one competitor is Redshift, which is a AWS product. Another competitor is BigQuery, which is a Google product. Raghvendra again is asking, sir, can you please explain what is the difference between horizontal and vertical scaling? All right, so this is very simple. So I'll just give you one diagram. So using the diagram, it will be easier for me to explain you. All right, so I think this makes sense. All right, so this diagram you see here, right? On the left-hand side is, I'm explaining, this is explaining the vertical scaling. So simple, in very simple terms, right? When you increase the power of same machine, you keep increasing the either the compute or storage, whatever, but the capacity of same machine. So let's say today you have a laptop with the configuration of 16 GB RAM and 1 TB hard disk. Let's say you need more compute and storage and you upgrade your laptop, same laptop, you install 16 GB more RAM, and instead of 1 TB, now you plug in 2 TB of hard disk, right? So that means you are using the same machine, but increasing its power. That is called the vertical scaling. You are increasing the size of machine. So smaller laptop, then bigger, and increasing the power of same machine. And horizontal scaling means you have a multiple smaller machines. So you have multiple smaller, let's say, servers, and you're connecting them in a network. So whenever a request comes, you're just utilizing all the machines and processing that request, right? And if you need a more capacity, then instead of increasing the machine size, you will add one more machine to it in this cluster. This is called the cluster. So if you increase the count of nodes inside the cluster, that is called horizontal scaling. Now, what is the difference? When to go with what, right? So when you're dealing with big data, right, or very big applications, then vertical scaling has some limit, right? In a single machine, there is some limit you can increase the compute and storage power or capacity, right? After some time, it will be, it will not support your scaling, right? But in the horizontal scaling, you can add more and more smaller nodes and put them together in a cluster. So this is the basic difference between vertical and horizontal scaling. Pratik is asking, if it is complete SQL, then how does it handle distributed compute ecosystem like Spark or ML required for big data, since SQL has limitations? Also, how does it handle no SQL data? So guys, this is not a complete SQL database. It is just, it is the additional feature that it supports SQL, but it supports your Python or Spark processing as well for machine learning and NoSQL. So Snowflake is a common cloud data platform which supports SQL as well as NoSQL workload as well. Again, difference between Snowflake and Red Shift. Naveen is asking. Yeah, I'll come to that. Bansi is asking, hey Rahul, can we integrate any database with Snowflake? Integrate any database with Snowflake? I don't get it. So you need not to integrate any database with Snowflake. Snowflake itself is a database. Yeah. Now I'll come to a question which is asked a couple of times. I think Naveen only asked the difference between Snowflake and Red Shift. So guys, for that, I'll go back to the one of the slide to explain you the difference between Snowflake and Red Shift. So this is the difference, guys. So let me just. So Redshift again is a cloud data warehouse platform, but the core difference is Redshift works with a shared nothing architecture. What does this mean is, so you can go ahead after this session and try it. When you go on AWS console and you create a Redshift account, right, or Redshift cluster, you have to tell in advance what machine size you need for your data processing, right? So they come with different machine size. So as I mentioned, let's say 12 GB RAM, sorry, 16 GB RAM and 1 terabyte storage, or 32 GB RAM, 2 terabyte storage. That machine size you have to give in advance. And let's say you only want to increase the storage, don't want to increase the compute, that you cannot do in Redshift. You have to move to bigger machine for storage increase, but by default, your compute will be increased and thus your cost will be increased. So that's the biggest drawback with Redshift. It works with share nothing architecture. Storage and compute is tightly coupled in Redshift, which is not the case with Snowflake. So you know it, right? When you saw this, when we created the Snowflake account, it never asked us what kind of machine you want, how big machine you want, because it can be scaled automatically, scale up and scale down. And you need not to give anything in advance. So that's the one of the biggest drawback of Redshift and the feature of Snowflake. Naveen says Redshift is based on Postgres. What about Snowflake? Yes. So underlying database is Postgres in Redshift, but Snowflake, there is no, so they have written their own file format. And so they store their data in the object storage bucket. And it's not on Postgres or SQL, any predetermined databases. So they have their own proprietary file format where they build this database ground up. That's why. So you see, Redshift is based on Postgres. That's why it has some limitations. But Snowflake is designed ground up. So there is no, they have their own proprietary format. I don't know what they call it, but it's not public. All right. Harsh is asking, is Snowflake more safer than decentralized? I didn't get it. When you say most, what is, I mean, what do you mean by decentralized? I don't know. Types of schemas supported is relational, semi-structured, and unstructured. And there is a, guys, a nice quick story about Snowflake, right? How it got created, right? So there were two Oracle veterans, so two database engineers who closely worked in the team when the Oracle was getting built for almost 10-15 years. And they saw some of the, because they won't build the Oracle, they themselves part of team which built the Oracle long back. And sometime in 2012, they pitched the idea of cloud data warehouse platform with isolated compute and storage to Oracle CEO that time. But Oracle CEO declined their proposal that it will not work in the industry. So they resigned from Oracle and founded this company called Snowflake. For next 3 years, from 2012 to 15, they built this architecture from scratch, right? And on 2015, they launched it first time on AWS. And that's how this started. And today, as we speak, as I mentioned earlier as well, top most of the top 500 for Fortune 500 companies are using Snowflake for cloud data warehouse strategies. And I'm also using Snowflake since last 4 years in various organizations, and it is getting so much traction these days. So if you're looking to get into data engineering, data warehouse, anything related to data related jobs, or if you're looking for jobs, if you want to switch your job into data domain, then this is very important to learn about Snowflake, because it's not only database, not only a data warehouse, it's a data platform, which means you can write your machine learning models, you can execute your data science workload on Snowflake. It's a basically one-stop shop for all your data needs, right? So it's very important if you're looking your career in data industry or data domain to know or explore about Snowflake. All right, guys. So I think that's it for from my side. I know there is a lot to explore about Snowflake, about cloud data warehouse platform, but time has their own limitations. So in one session, it's very difficult to explain everything, but I can guide you to some of the resources which you can look for to understand more about Snowflake and cloud databases. So if you go to youtube.com, I'll just paste some of the link as well. and you can search, for example, is Snowflake in 8 minutes. Sorry. Right, so it says what is Snowflake at 8-minute demo, right? So this is these kind of, and this is from Snowflake channel itself. So you can go through Snowflake channel and you can watch some of the videos available which explain the working and detailed functionality of Snowflake. Or you can simply type Snowflake demo. Just remember, you go to authentic sites like Snowflake INC, and you can just, you see some of the like Python on Snowflake. So somebody asked, is it only SQL? No, it is not only SQL. You can write Python as well on Snowflake. So these are the new features which are coming. A lot of excitement going on these days, guys, on Snowflake. So make sure you explore this as well. Yeah, so that's it from my side, guys. Feel free to ask any more question if you have. So Naveen, I see some of the question in chat window. Naveen asking, can we pause the Snowflake cluster? Can we schedule query in Snowflake? Yes, Naveen, you can. So automatically, when you are not using Snowflake, that's the beauty of Snowflake, that if you're not using, the cluster will be automatically paused. And when you start executing your query, it will automatically start. So definitely, it will be automatically paused and start. And can we schedule query? Yes, yes, you can schedule queries in Snowflake as well. So all the ETL related things, scheduling a job, scheduling stored procedure, queries, everything you can do in Snowflake. Pratik is asking, how can we prove that we know Snowflake for job switch or even freshers? Yeah, there are some certifications which are provided, conducted by Snowflake. You can participate in that. So if you search here, if you guys are interested, you can search Snowflake. Obviously, after you got the knowledge, then only opt for it, because these are expensive certifications. So you can appear for Snow Pro core certification. This is what I did last year. So you can also go through it. And after that, there are some advanced level certification, but you don't need right now. To start with, you can go with this certification, Snow Pro core certification. But obviously, after acquiring some knowledge and some hands-on. Naveen is asking another question. What about backups? Yeah, so Naveen, any cloud platform, right? It automatically takes a backup and replicate your data in multiple locations. So that is automatic. Everything. So whatever database administrator used to do in Oracle or SQL Server, that is no longer needed in Snowflake. Backups, restores, recovery, disaster recovery, right? Patching, everything is done by Snowflake. So you need not to worry about it. So host is saying a participant can unmute themselves to ask any question if they want to. Yes, guys, feel free to unmute yourself. Naveen says, you mean there is no data loss? Yes, no data loss. Because your data is replicated 3 times in different geographies. Manit is saying, can you explain about the database storage layer of Snowflake? So Manit, it depends on the underlying cloud provider. So suppose this time we created a Snowflake account on AWS, right? So if you're using underlying cloud provider is AWS, then Snowflake will store your data in S3. There is a service in AWS called S3. There Snowflake will store your data. Similarly, if you're using Azure, it will store your data on blob storage. All right, guys. So there is a lot of happening, very interesting things going on with respect to Snowflake and data industry. And I'm very much active on LinkedIn. So this is my LinkedIn profile. I'll just put this on the chat window. And I keep sharing a lot of things about data engineering, Snowflake, etc. And I just pasted my LinkedIn profile in the chat window. Sorry, I'll share this with all. So you can just stay connected over LinkedIn, and you can just directly message me if you need any assistance and all. Naveen says awesome presentation with inevitable information. Yeah, still I feel I could have done more, but I can talk about Snowflake or data engineering for like hours, right? But in this forum we have limited time. Yeah, so stay connected, and keep exploring, keep writing to me. And Pawan says thanks for amazing session. Yep, thanks Pawan. So that's it from my side, guys.